Alright guys, let's solve the Leetcode problem. So yeah, the Leetcode problem is okay. Let's reset my cache. Finding the maximum number of elements in subset. I don't want to judge the people who create this question, but this is literally not worth it to begin a Leetcode problem. Anyways, since it is a Leetcode problem, we have to solve it. So we are given an array of positive integer or positive integer in the nums array, and we need to select a subset of a nums which satisfies the following condition. So the condition is we could be x to the power of something like, maybe I create the 5x in here because 3x will be the weird name, xxx. Alright, not sure this will be got sense or not. So that would be like 2, 4, and 2. So they want the subset is going through the pattern like x power 2, x power 4, and drop back to x power 2, x squared, and x. So we have to note that k can be any negative power of 2. So all the power inside here should be the positive integer, cannot be negative. For instance, so if we expand that into the appropriate values, that would be 2. That would be like 2 in here, 2 in here, and then we increment to the 4 and double to the 4, which is a 16, and go back to 4, reset back. The same here. So 3 power 3 square is 9, and drop back to 3. That's the same pattern. Okay, so we cannot be like this. We can be like exponential grow and then exponential drop back. So we have to retain the maximum number of elements in the subset that satisfying this condition. So by counting that, let's say this is a 3 subset, this is a 5 subset. So by checking the example 1, we're given like 5, 4, 1, 2, 2. So the only thing we can find is that 2, 4, and 2 is a great candidate to perform the, I don't know what is the subset, the generation. It's like that. The same for here, so we can't generate any of the subsets, so only one. Alright, let's solve this problem. I have no idea how can I enable the Vim. There we go. Alright, cool. So what I want to do is I want to keep track of the frequency by number by using the integer dictionary, which is maybe, okay, that's my style. Okay, and after that, what I was thinking is, how about we populate the dictionary for us to use in the future? So that would be numbers in nums. Maybe nums is better. So we will do like frequency number of num default values will be 0 and plus equal to 1. So by doing that, we will have a value like something like, for example 1, we will get like 1:1, 2:2, and 4:1, and 5:1. So that's what I'm doing for dictionary. And we also want to keep track of how many ones count we get in here. The reason to calculate for one is especially for the drop at exponential gates, which is going to be the frequency by number of 1, and default is 0. And we may also need the reset for sure. That's going to be the max of, maybe just put 0 initially first. And then what I'm going to do is I will go through all the keys because the value are useless for us at the same time. Frequency by number of keys, and I will got like if number is not equal to 1, I will continue. If not, there's no reason for us to continue. So let's keep track of current length. It's going to be 0, and we need a condition like y. Frequency of by number of num. Wait, I think we need a one num in here. Let's call current number because we need to edit the number also. So let's call current. I don't know why I keep writing num today. So current num, and if the frequency is better than 1, greater than 1, I will increment the current length to 2 because we are converting with like left 2, right 2. So that is approach. And then I will increment the current number with the current number so that we can perform the exponential pattern for the growth. And yeah, if everything went well, what can we do? We will apply the reset, but we still need to apply the current length first. Current length will be the, I really hate this long naming. Frequency, number of current num, is not equal to nil because this is dictionary. Then we return 1. If not, we put the -1. So the reset will be the mass of reset and return the reset. Let's try to run locally. Alright, let's check it solve all the problem or not. Oops, okay. We need to tweak in here because we don't think for the 1 case, because if the value is 1, 1, that is not the valid case. So that is the reason why I'm creating the 1 counts in here. And take the 1, if 1's count is divided by 2 is equal to remainder of 0, we will return the 1 count minus 1, which is like if divided by 2. So let's say we have 4 divided by 2. So we can remainder is 0, so 2 minus 1 is 1. We can return the 1. But if not, we will return the 1's count. Alright, let's try it again. And submit. Ooh, nice. I can't even imagine my runtime complexity because this is so messed up solution for this tiny little problem. It's O of n log m, but it's okay, at least better than nothing. And memory is O of n because we don't use any spare memory aside from using the default dictionary count same side as the nums. Alright, hope you guys enjoyed this video and then see you in the next one. Bye.